So, hello and welcome to the next block. I really hope these are ordered by random and not by anything else. And so there are a few more talks pending about geometry, buildings, etc. And I will start with OSM Buildings, OpenStreetMap rendering for building geometry. Hopefully, a few of you know the project already and have already played with it, but I'm trying to show you a few more details about it. First of all, my name is Marsch. I'm working for Car2DB right now. Probably a few of you know this, but it's not really related to the project. Project OSM Buildings stays independently from this. Okay, so let's see. It works. Okay. What OSM Buildings mainly is about, if you remember all the talks before, this one just fills the gaps which are behind, so it's suitable for a bit slower devices, for devices not really capable of handling WebGL, and it also does a few effects which can be done in WebGL, but probably not that easy to achieve. So I think it's, right now at the current state, it's a good complementation to this, and maybe that's one of the next points. It can really work together with the new WebGL version. But let's first get a bit into it. Like all the other projects, it also does a dynamic perspective. When you move the map, it's not just placing the buildings in a static way, but the whole thing is using a pure 2D technique. That means everything you see is calculated polygons in client-side, not in GPU, not using WebGL. Always keep this in mind because the speed is, of course, different. It has a lot more disadvantages over a real powerful GPU, and it requires a bit more tricks on the client side. But as said, advantage is to run on a bit slower devices which don't have powerful CPU, and it runs, for example, on most iOS devices. It has a few render modes. It's not just static blocks or not just simple blocks. We have a sketch mode, which I show you in a bit. This one looks a bit like a hand-drawn mode of polygons. There's also a 3D mode, more or less pure 3D mode, which renders different perspectives and overlays them, so you can watch them with the 3D glasses. So, to be precise, it's not 3D glasses from a TV, it's like the red cyan version of 3D glasses. So, let's come to a few demos, not what it really looks like. I opened the city of Warsaw, the Polish capital. The reason is it is quite good mapped. It has lots of attributes on the buildings, and hopefully I can show this to you a bit. Yeah. So if we go a bit in, so you see that's I don't know, it's Kulturpalast in German. So it's really it's a huge building, and you can see the effect. So we have color calculations, we have all the geometry calculation in client side, and if you notice that, we also have the shadow calculation for each object. Something which is missing on a few WebGL engines, but I guess it's really easy to do. So, just one example, a bit more impressive in terms of size is probably the city of Dubai. So let's find a bit taller building. If I'm right, it should be somewhere here. No? Yeah. So, loading. I was told the network is stable. It is? Okay. Yeah. So let's try reload. Ah, yes. Okay. Now we are too close. Of course, it had to happen. So, okay, here we are. Yeah, just to show you this, what it looks like, even the shadows. But the shadows are not calculated on local time in Dubai. Just in case somebody wants to verify this, it applies to local time of the browser, which is this time zone here. So that's the normal render mode, you see. And I have something else. I have opened the Warsaw example as well in the sketch mode. And you will clearly notice this is a lot slower. I will explain that in a moment. And so you can create some artificial effects. So like really intentionally being not photorealistic, like doing some artistic stuff. So reason because that's a lot slower is that we don't have straight lines, which are easy to calculate and easy to render. This is all curves and Bezier curves to be precise, and there are a lot more points involved and a lot more geometry calculations involved. That's why it takes a bit longer. So, all right. I'll show you two more things. You don't really need to have buildings for this. The engine can handle any kind of data or specifically GeoJSON data. For example, you can draw just a few things on a map. It can easily handle it. So I can change the size, whatever. So. Yeah. So, and you always have the correct shadow attached. So, and again, one more thing about the shadows to go a bit into detail. Let's take this building. Of course, this is really real time, or it can act real time. I'm calculating the sun position. I mean, I didn't really invent the formula for this, but I'm doing this in the most correct way and apply this to all the geometry. So you can easily play with the days. You have a change in there, and of course with the times. So one thing which is already mentioned in the text, so if you go past or go into October, you have that jump for the daylight saving time. So that was it, somewhere end of October. All right, yeah, feel free to play more with it. There are a few more examples, and there are also, besides all that fun stuff, there are also a few real projects using it. All right, so back to the theory. The whole thing is not trying to create another map, not a whole map. Like most of the WebGL engines are also creating a base map, so like start drawing roads and etc., drawing parks, trees, etc. I'm aiming for being another layer on top of an existing map. In this example, mostly I'm using Leaflet for doing this, but it can be right now open layers too as well. There are also a few preparations for Google Maps and different other engines, but it depends on how everything goes on. And in case of Leaflet, it's really simple as a few lines of code. You have to include the library, and you have basically it's one line of code applying the whole system to an existing map. And if you already have something like routing on a map, so which is another custom layer, this is not really influenced, so you can stack all the layers which you already have. You don't really need much knowledge for using this. So in order to have the whole thing fast, of course I have to handle a few things, and I have to apply a few tricks. Not everything can be done like in WebGL. So I'm using basically or mostly OpenStreetMap data. And OpenStreetMap data is in general not 3D data. It has a lot of polygons, and in case of buildings, it's just flat polygons or multi-polygons. And if you are very, very lucky, then there's also a height attribute set to all these. It can be also building levels, which somehow in turn into height as well. But that's the minimum I require. And then, after having the footprint polygon, I can calculate the roof line, which you see here. And it's even simpler. I just assume the roof is at the same height on each point. I mean, in reality, that's not the case, but it makes things a lot faster. The data I'm using for this can be, like I said, OSM data, but here I prefer the JSON format, because there's not much conversion on client side for this. Ideally, it would be GeoJSON. That's one common standard. I can already handle this either by just a variable holding a lot of GeoJSON information, or it can be any service somewhere in the web providing GeoJSON. And CartoDB is just an example for this. You can query whatever area you want, and you can have the data returned in GeoJSON. The preference is clearly on OSM, because coverage for most big cities is quite good already, and I can filter for buildings. In this case, I don't have to handle the whole OSM data package, just a bit of it. I'm also planning to have a building repository. To be honest, this is already in the works and quite far. This one is intended to have like a unified interface to several open data sources, which can be various formats. So most governments, at least in Germany, provide shapefiles, few provide KML files, and others have some really weird WFS service. So this is very strange, and we want to have this a bit more simplified. In this case, I'm trying to convert the data and ideally provide just GeoJSON. So this is more or less a side project out of it. So the data is not loaded as a whole full screen or a whole screen bounding box, but it is split into tiles. And with that, I can, really similar to the vector tiles you've already seen, I can request at any zoom level, I just ask for one tile at a certain point. And if I zoom in further, I don't need to ask for that same tile again. And I'm not splitting the tiles any further. So really, if I have, for example, if I have at a certain zoom level a whole screen covered with tiles, I ask for them, I load them, I show them. And afterwards, if I zoom in, I don't load anything else again. I just use the same vector data. There's some simplification done on client side. So I'm doing all the filtering, simplification there. And so I always have proper data on whatever zoom level we currently have. It saves a lot of bandwidth. So it's not only the data to be loaded, it's also the rendering itself. It has to be a bit simplified. For example, if you have objects like cones or like cylinders, in, for example, WebGL, you would have to render a lot of faces for this, but then it also, of course, looks very nice. And I can't really do this simply. In that case, I'm doing a few 2D geometry operations in order to, for example, if you look at a cylinder, we have two circles which have to be connected by tangents. That's few calculations more on client side, but at the end, I have very few rendering operations. And that's the one what counts. So for example, for that one, only 2 fills, 4 strokes. That's very, very few operations in order to achieve this. And the biggest bottleneck I encountered is really fill rate. Whatever shape you're drawing, if you have to draw many, many pixels, that's costs. Calculations are not that costly. Another trick is like layered rendering. So if you see a few tall buildings, a lot of flat buildings and shadows. I'm not calculating them on each movement and not on each event, because that's simply killing the performance totally. I split all these up into, right now, 3 layers. I have the shadows on the ground, which are updated very rarely. For example, if you move the map, the shadow basically doesn't change. So I can redraw this once the map is repositioned. I have the flat buildings, that's the more or less yellow ones here. These don't really have perspective, as they are very, very flat and very basic. So they behave very similar to the shadows. I can redraw them very rarely. So that leaves only, it depends on the city, of course. It leaves a lot less buildings which are tall and which have to be handled very precisely. So, the comparison and where we are. It's of course not photorealistic rendering, and for a long while it will stay like this. It's planned to handle it differently, but not for now. The goal is more like keeping it running on mobile devices, especially on slower devices, especially on iOS devices. Also taking care for the visuals, always taking care for it. I don't want to have this looking like a, like a data visualization. It should be a bit more appealing. So, of course, we have the shadows, we have the anaglyph mode. That's something other engines can do, but most of them currently don't do. And the whole thing stays performance critical. It's also performance critical regarding to my persons, because I'm doing this all alone. And I would be really happy to talk to another team or to talk a few people in order to enhance the whole thing. And hopefully somebody will get back. So that's the nope slide. I think the last line is missing, hopefully. You can get it to work, yes. Okay. So, of course, the way will be to go a bit more WebGL direction, but I don't want to replicate what we already have. For example, top left, Busy Cities. I hope a few of you know this. A very nice project, and as far as I know, it's done with 3JS. It's not so detailed and it's not perfectly nice, but it's extremely fast and very, very good to use. Another one I like, but with drawbacks, is the F4 maps. Visually, it's by far the best thing I've seen, and they're also very close in getting this photorealistic and to do a bit more than just gray blocks. But biggest drawback is it's not open. Even if they claim it's all open source map, etc., it's using OpenStreetMap data, but it's not an open engine. You always have to be careful about this. I also want to mention OSM to World, even if that's not a fully dynamic perspective map rendering, and the colors, okay, we can discuss. But in general, Tobias has done a very, very good job in geometry processing for this. It's probably not all visible, but he does calculate a lot of things to be as precise as possible to reality in terms of polygons. So this one is really, really nice and probably a good cooperation in terms of data. And the newcomer, at least the newcomer to me and probably to the whole OpenStreetMap rendering, is the map from MapZen. In a few aspects it's quite close to what I would like to do. So at first, they're not really trying to make everything in a tilted perspective. I mean, we can do that, that's fine, but it doesn't seem to be a priority so far. And also, I've seen from the code, they're not doing so many fancy things, but seem to be creating a bigger framework, and there seem to be bigger ideas behind the whole thing. And like written, let's talk. I think this is very promising, what you're doing. Finally, the plan summed up. WebGL, yes, the topic. Like I said, it will happen, but I don't want to replicate what we have. We clearly need better data for this. Ideally, it can be something like photorealistic rendering, but that's far away and it requires a lot of manpower, something I can't provide at the moment. The building data repository I mentioned, yes, that will come at some point. Integration with Cat2DB, not anymore, like you see. So, yeah, if it makes sense, maybe I will integrate this somehow with Cat2DB, but the whole topic is different. One thing, buildings, the other thing is like creating data on the map. We will see what happens. There are also a few visual effects, which are usually a total performance killer on 2D renderings, but I've done some very promising tests. I can't tell right now, but there will be a few more things like happening on the map in a dynamic way. And I can still do this in 2D. I also played around with the idea of raising the center of the map, like you've seen in the MapZen demo. So if you move around, so like buildings change the height, something that can be done easily in this engine. So it's not all preserved to WebGL, but we will see whether this happens. All the other things with question marks, yeah, totally unsure. It's nice to have, but we'll see. Yeah, finally, I've summed up all the links or all the most interesting links for you, and yeah, you're getting all the slides, and hopefully you can get a few more inspiration out of this. Yeah, that's it. Thank you. Are there questions? Yeah. Feel free.
Thank you. Not a question, a comment. Well, thank you for sharing that with us. Henk and I looked at your shadowing, and we sort of, I think we both came to the immediate agreement. With your ability to create simple buildings on the fly, coupled with your shadowing, there's a potential tool as a useful public service for looking at planning applications. Mm-hmm. Similarly, I think it's a problem in London at the moment, looking at the potential effect of reflection of new tall buildings.
Okay.
So thank you very much.
Yeah, you're well welcome.
I see buildings, when you draw buildings on a map, it always extrudes to a flat rooftop.
Yes.
So what if you have a roof that's a dome or something else? For example, you showed Burj Dubai, which was realistic. So what sort of extra details would I need to draw a building like that? How would I model it?
So if you're lucky, the buildings are tagged like this, so to have a bit more special roof shapes. But I can't draw many of them. It would be many conditions to handle. There are so many different roof shapes, and usually you have to do a lot of analysis, how the roof is really placed and how the shape really looks. This is something, just in case if you're interested, you should really talk to OSM World, because Tobias is doing all this work. What I can show is just one example of it. Thanks. Yeah, let's just go for Berlin. I mean, so this is trying to look like a dome, if you can see that on the museum in Berlin. In fact, it's not really a dome, it's a cut cone for the moment. I have a dome in place which just has a few rendering bugs right now, but within the next weeks, I mean, if you don't mind to follow me on Twitter, so you can see at least a few more roof shapes.
So is it mostly a layer on top of another layer? So there's a base layer with a flat roof, and then you place another layer, like a maybe cone?
How I render this, yes, I have the base building. This is one object, one object turned into 2D, and the roof is another object to render on top of it. Yes.
And to expand a bit on that question, which properties for buildings besides height is your library supporting?
What is important for the roof shape, or?
Not just roof shapes.
Okay.
I see some buildings have different colors. So which tags are supported?
Okay. Right now I'm supporting the building color. It has a few variations. There's also building facade color, and people are mapping this differently, but I'm trying to align all of these. So mostly building color. There's also roof color, and what I'm also mapping is materials. So you can define a building material and a roof material. And this is what happens here. So I didn't invent these colors, so somebody has tagged this either as brown or as a certain roof type or roof material. And I'm translating this.
And do you support building part?
Yes.
Tag?
Yes, that's exactly what happens here, what you see. That's several building parts.
Further questions? Or then I would say thank you for your presentation.
Thanks. You're welcome.